Hi, I'm Angus Atwood,
And I'm Flann.
and our project is on robot navigation without a map.
Or memory. We decided to do our project on robots because I really like to program.
And I like to build robots.
For this project, our question was, is it possible to program a robot to beat a maze without a map or memory?
The hypothesis is, if programmed properly and given enough time, a robot could beat any maze because it would eventually come to the end.
From our past experiences with programming robots to do various tasks and challenges, we thought it would be possible for a robot to beat a maze.
Our materials are a LEGO Mindstorms robot we designed and programmed ourselves, a personal computer, and various materials used to build different mazes for the robot to solve.
The interesting thing about our robot is that it is not programmed to beat any particular maze. It can beat any random maze it comes upon.
Our independent variable was various mazes.
Our dependent variable was the time the robot took to complete each maze.
Our controls were same robot for every trial, same track for every trial, the same stopwatch for every trial, same program for the entire first series of tests, different program for this entire second series of tests, the same location / altitude, temperature, etc.
The first thing we would do when running a trial is build a maze. We would mark the robot's goal at the end of the maze with blue masking tape. Then, when the maze was complete, we would run the robot through it and record the time in our notebooks.
In addition to our first question about building the robot, we also had a second where we ran two different programs to see which would work better.
Program 1 causes the robot to turn right or left corresponding to the right or left sensor that is pushed, and to continue going straight when the middle sensor is pushed.
Program 2 is essentially the same as Program 1, but when the middle sensor is pushed, the robot backs up, then randomly chooses to go right or left. We ran 50 trials in all, 25 per program. Each program had 5 mazes. The same mazes were used in Program 1 and Program 2. We ran the robot 5 times on each maze for each program.
Our data showed that the time it took to complete each maze grew with the complexity of the maze, and no matter how complex the maze was, Program 2 always did far better than Program 1.
The robot was quite good at navigating the maze. Through both of the experiments, in the future, the capabilities of robotics will become much more promising thanks to the discoveries of today. As humans find solutions to the limitation of programming, robots will continue to help humans with more and more tasks.
Hi, I'm Flann.
And I'm Angus Atwood,
Thank you for this opportunity.
and we hope you enjoyed our presentation.